I didn't run a staples. And there's special mini staples. So you can't get them.
They're not special, they sell them. It's standard size. Nothing high.
It's the hardest thing ever. Do you know your house staples?
I do. It's just really confusing
All right. Oh.
I just staple it at home.
Before I forget,
Yeah, I could do that.
okay. If you're a sophomore, this pertains to you. If you're a junior, it does not pertain to you. How many are scheduled? Raise your hand if you are scheduled to go to Breaking Down the Walls tomorrow, Tuesday. Wow.
Wait, will we still come here?
No.
Oh,
Okay,
yeah.
so okay, but let me just see. I just need to get raise your hand. I just need to get an idea of how many of you. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so stop asking you. Put your hands down. Thank you. So our class ends tomorrow at 8:05. I believe that the activity starts at 8:05. Does it start at 8:05 tomorrow?
Like 8:10 or something.
Okay, so don't quote me, but if it doesn't start, the activity doesn't start until 8:05 or 8:10, then you should come to class. Do you have to? I can't answer that, but I would come to class. Okay? Yeah? Fantastic. That's the beauty of zero period. Okay, so polar coordinates and graphs. If I ask you to plot the point, I'm going to combine my rectangular and polar graph together. So 1, -√3. So 1 is your x. Y is -√3. Agreed? So if I was going to plot that on a rectangular system, this is my x, this is my y, where would 1 -√3 be? Fourth quadrant?
Yes.
Okay, I don't know. -√3 is -1.7-ish. Right? Okay, so 1 -√3 is like here. That's a big ish. Okay. Why is that -√3? Because it's approximately 1.7. So this is 1, 2. So it's between 1 and 2.
Wait, isn't x the radius though?
I'm doing rectangular coordinates.
Oh.
Doing rectangular coordinates. I'm going to superimpose them together. Let's convert this to polar coordinates. So I want to convert this to our theta. What's that look like? So I'm not sure if we got to this on Friday. What's the equation of a circle?
Higher square.
The equation of a circle is not pi r squared. That's the area of the circle. X squared plus y squared equals r squared. This is how I can find r. How can I find theta? So go back to your unit circle, your sines, tangents, cosines, all that. Go back to your relationships. Ryan.
Tangent theta equals y.
Tangent of theta equals y x. So this is how you're going to convert, excuse me, rectangular, polar. Rectangular, excuse me, rectangular, you know x and y. Rectangular, you know x and y. Plug in for x and y, and you can convert. So, plug and chug. What's x, what's y? Hopefully I did the tangent correctly. I gave you x and y. What are they?
and negative root
1 and negative root 3. Plug in. Tell me what R is. Plug in. Tell me what R is. I'm hearing R is 2. I believe so. R squared equals 1 squared plus negative root 3. R is 2? Yes? Okay. Now you got to figure out the measure of theta. So the tangent of theta is y over x. Okay, hopefully I made this up. Hopefully I made up a good one. Jason? Jason says negative pi over 3.
Or it could be 2 pi over 3.
Or it could be 2 pi over 3. Y is negative root 3.
Negative pi over 3.
No negative. This is not an inverse function. I'm not asking you to solve. I'm not telling you that the inverse tangent of negative root 3. This is not the same thing as telling you the tangent equals negative root 3. These are different. This involves the domain and range of an inverse tangent function. This does not. Okay? You see the difference? So, what's theta? 2 places. Where's tangent negative? 2 and 4. Hold on. Tangent is negative in 2 and 4. Agreed? How do I know which one it is?
2.5, not 2.
It's 2 and 5, that's 4.
Tangent? There is no fifth quadrant.
Oh,
Quadrants. Quadrants. 1, 2, 3, 4. Where's tangent negative?
2 and 4.
2 and 4. What's wrong?
No, sorry.
Okay, I didn't hear it, so we're fine. 2 and 4. So what are your 2 options for theta? This is like the big part that you're going to be confused about. Where does it go? Does it go in 2? Does it go in 4?
But it's a
So, yeah, hold on. So theta, my options are 2 pi over 3 and 5 pi over 3. How do I get that? I know my unit circle. It's a 60-degree reference. Okay, tell me I have that right.
Yes.
Do you agree that there are 2 places where the tangent is negative root 3?
Yes.
Tangent is negative in 2 and 5. Jason's not even listening to me. Tangent is negative in 2 and 5. 2 and 4. So the question is, which one is it?
5 pi.
Why is it 5 pi over 3?
Because y is negative and x is positive.
The rectangular coordinate lies in 4. The rectangular coordinate lies in 4. So my answer must be the 4th quadrant. It's based on where does the rectangular coordinate lie. So what is this overall point converting 1, comma, negative root 3, rectangular? What does that look like in polar?
2, 5 pi over 3.
So you can't go like negative pi over 3.
No, because that's what we're doing up here. This is not the same as this. No. 5 pi over 3. Yeah, Jason. I'm sorry, Ryan.
Wait, why did the back of the book went in did inverse tangent? Like when you check the answer in the back of the book, they did inverse tangent.
Okay.
And a negative.
Okay, so let's do, we left off, hold on 1 second, Ryan. So we left off on, I'm not ignoring your question, I'm going to tie it into something else. Do they do a negative radius or a positive radius?
They had a positive.
Okay. let's plot the point.
They have one.
4, 5 pi over 6. Plot the point 4, 5 pi over 6. When they're asking you to plot points, you can do 3 or 4 of them on the same grid, that's fine. When we start graphing shapes, you can only do 1. You'll see what I mean in a minute. Plot the point, and let's label it A. Was this a direct problem from the homework?
They did.
I see what you mean. Did you plot it?
Oh,
Where is it? Where is 4, 5 pi over 6?
Quadrant 2 on the fourth
Okay.
radius.
Fourth circle. R is 4. Each circle represents 1 unit. Yeah? 5 pi over 6. So my little grids go by 10 degrees, or whatever that is, pi over 18, I think. So this is 150, which is 5 pi over 6. Each circle, or each, I should say, segment, each, it's an array. What do you call these? The radius of the circles, what do you call the ticks, the lines? Yeah, I'm not sure there's an exact name for it. All right, so fourth circle, 5 pi over 6. 1, 2, 3. Agreed? There are 3 other ways to write this angle, and you have to know all the different ways within the domain of 0 to 2 pi. I want you to find the coordinates. Let's do greater than 0. R is greater than 0, and theta between, let's do 0 is less than or equal to theta, which is less than or equal to 2 pi. We just did this one. Let's do with less than 0. Sorry. There are 4 ways to get to pi over 6. 5 pi over 6, sorry. There are 4 ways to get to 5 pi over 6 with a radius of 4 or negative 4. Radius is negative, less than 0. How can you have a negative radius? It goes backwards. Negative radius goes backwards. So here's what we did. We found 5 pi over 6, and then we went 4 spaces for radii towards the 5 pi over 6. Agreed? Negative radius, you would find 5 pi over 6 and go the opposite direction. That would be a negative radius. So where does my angle need to lie if I want to use a negative radius and get to 5 pi over 6? Fourth quadrant. Fourth quadrant, what angle is that? What's 5 pi over 6 in the fourth quadrant? 11 pi over 6. Pi over 6. So instead of from the origin going towards positive 11 pi over 6, this would be positive 4. Negative means go the opposite direction. So how can I write that point? Let's see.
Negative 4, 11 pi over 6.
These 2 points. So this is r is greater than 0, 0 less than or equal to theta less than 2 pi. Range is the same, domain is opposite. There's 2 more. I can write a, hold on, I've got the domain backwards in my head.
Positive r, and then negative 2 pi.
There we go, that's what I was doing. Thank you. Positive r, negative 2 pi, less than theta, less than or equal to 0. If I want a positive radius, what value does that have to be?
4.
4. Positive radius has to be 4. So the question is the angle. It has to be some denominator of 6.
7 pi over 6. Negative 6.
This means I need to find an angle and go towards, start with my radius at the origin, which is 0, and go towards the measure of the angle. So, how do I get to 5 pi over 6 going in the negative direction?
Negative 7 pi over 6.
Negative 7 pi over 6. One more. So there's 4 ways. Well, there's an infinite number of ways. You have to know how to do all the ways. So now we need to do r is negative and a negative theta. Okay, so if I'm going to have a negative radius, which quadrant do I need to originate in?
4.
4. So I need to originate in quadrant 4. And I need what kind of angle? Positive or negative?
Negative.
So where is my, you said my angle needs to originate in quadrant 4. So how do I get to 11 pi over 6?
Negative pi over 6.
Negative pi over 6. Negative, what is it,
4.
negative 4? Negative pi over 6?
Yeah.
Okay, so going back to the question about the tangent and the answer being negative pi over 3, what do the directions tell you to do?
61 was converting. No,
I think it can be.
Right, so there's technically 4 answers.
Yeah.
Well, if you're going, it doesn't matter. There's technically an infinite number of answers. So yes, that would be okay. That would be okay.
So as long as you give one of the answers.
Well, I'll give you a domain, or a range,
Oh,
I should
okay.
say. I'll give you a range. I'll say from 0 to 2 pi, or from negative 2 pi to 0, whatever. So I'll because that's a little bit confusing. How do you know which one to do?
For these specific, if you look at measure of degrees, should we
You should always use radians, but you should always use radians unless I tell you otherwise. Our degree days are pretty much over.
calculator for like there was one.
Oh, was there one that didn't have a nice tangent?
They used degrees.
Okay. I'm not
Degrees
No.
on the right.
I'm not going to give you one that requires a calculator because you need to know you're in a circle. Okay, let's do one with going the other direction. I erased it. So polar to rectangular. I think polar to rectangular is a much easier option. So several of you did the homework. Great. How do you go from polar to rectangular? This means you know r and you know theta. You want to transform it to x and y.
X equals r cosine theta,
X equals r cosine theta.
and y
Y.
equals r sine theta.
I erased the other one. I don't know why I erased it, but those are the 2 biggies. Those are the 2 biggies. All right, we haven't done equations, and there were no equations assigned to you, so this is, well, all this was new, but let's go through equations. Okay. I want to write the equation using polar coordinates. How do you know that you're currently in rectangular?
X and Y.
X and Y. Polar coordinates or polar values, what do they say? I want to use the same language they use. Polar coordinates, okay. Ryan,
Why does it say x squared plus y squared equals x?
that's
That's
rectangular.
what it is.
Yeah. By the way, what shape is this? No, I'm in rectangular. No cardioids, no lemicons, lemisons. I don't know how to pronounce it. Lemicons, lemison. I believe it's lemison. It's got the. Forget it. We'll get there. You got an x squared and a y squared. What's it equal?
Circle.
Yeah, it's a circle. It's a circle. How do I figure out? Let's do it. We're here. How do I figure out the coordinates of the what you call it? The center and the radius. Ooh! Complete the square. Let's do a little side note first. X squared minus x. Leave room to complete the square. Uh-oh.
Radius.
What just happened there?
I know, but we'll add
No, nothing will
something.
happen because you're completely squared.
We're going to add something. So initially, thanks, copy. I'm looking at it. I'm like, huh. Go for it. Complete the square. Finish it. Center.
So, what,
How do you complete the square?
0.25?
No. Decimals. No.
Plus 1/4.
You completed the square like, oh my God, so much last year when you were doing hyperbolas and ellipses and parabolas and circles.
It's been like
It's 1/4. It's 1/4.
However, that one has to be like a fraction.
Avi, you not remembering and then it not being covered are two very different things.
We like covered it at the end of the semester, like the first
You should
semester.
remember it.
Right? Like hyperbolas and parabolas and
Tangents. Kavi says, we covered at the end of the semester. Hyperbolas, circles, tangents. Seriously.
It is 1/4.
It is 1/4.
Oh, you were like no fractions.
Oh, I thought somebody says 0.25. I said no decimals. I didn't say no fractions. If you're going to quote me, at least quote me correctly.
I heard no decimals.
I did say no decimals. It's never a bad idea to review where did the 1/4 come from. Yes, Jason.
Wouldn't the right side negative or 1/4 be negative? Because it's positive.
Here? No. You added 1/4 to the left. You add 1/4 to the right. Yeah? Where's the center? Oh, you didn't answer my question. Where's the 1/4 come from? Yeah, half of B
Half of that square.
and then squared. So half of B is negative 1/2. Squared is positive 1/4. You're always adding because when you square, you can't square and get a negative unless you're in the imaginaries, and we're not going to graph imaginary conic sections. So the center is at 1/2, 0, and the radius equals 1/2. And then from the center, 1/2, you'd go up a half, left a half, down a half, right a half. Yes? Great. Convert it into polar form. Convert it to polar form. You can do it. I have confidence.
Like, oh, it's not data squared.
I read the equation. I thought it was.
David, you do it?
No, I'm thinking.
I am.
You're thinking about something besides converting that equation to polar coordinates, which I know is like the most exciting. It's a great way to start your week.
What?
Converting an equation into polar form.
100%. I just look forward to this one all weekend.
Maybe there's some confusion. Convert this, the original, sorry. Convert the original.
No.
Convert the original, sorry. I just made you do a side note. What's x squared plus y squared? What's x squared? Where is it? We just erased it. Must know. Must. This is polar rectangular. This is rectangular. Polar. How do you know? If it's rectangular, y's and x's has nothing but y's and x's. Rectangular, to convert it to polar, blah. So, help me out. What's x squared plus y squared?
R squared.
R squared. Woohoo! It's a straight substitution. What's x?
R cosine theta.
Oh. Okay. So there are a couple things that math books do that I am like 100% opposed to. One of which is they use this word that I refuse to say aloud. Your Algebra 2 Honors book uses that word. All right. If I told you to solve for R, we're going somewhere. If I told you to solve for R way back before I used to yell at you, what would you do? Divide by R. And what? and how do I feel about that?
You can't divide by
No, you
variable.
can't divide by a variable. It's not even like how I feel about it. When you divide by a variable, you eliminate solutions. This is something that you guys were doing with the increasing and decreasing, and it ended up being like x squared plus x equals whatever it was. Okay, I can't think of one, but it didn't work. So your book divides by R. The jury is still out on that one. This is it. I would leave it this way. That's it, Miss Babiak? Yeah, that's it. That's the answer.
Oh,
That's it.
thank you. But then
So your book will divide by R. I will say, but Miss Babiak, the book divides by R. No, you do not divide by a variable. That is so voodoo. All right, let's do another one that it's hard to know. Like, when am I done? How do I know if I'm supposed to divide? How do I know if I'm supposed to multiply? Whatever. Okay, so we're going to do one more lesson, and then we're going to grab some totally awesome, fun things.
Wait, what did you erase?
Why did I erase what? I need more room to write.
I mean,
Well, Javi, I can only,
whatever.
what I need to do is get one of those sliding boards.
Oh, those are coming back.
Yeah, Mr. McGurk has one. He just slides back and forth. Oh, I like
It's not
really
really
jealous.
jealous.
Yeah, it'll be like 20 years from now. All right, let's do one more. 74. 4x squared y equals 1. Same directions. Same directions. Is that a Spanish word or am I making them up?
You're doing great. You're doing great. Where's my
Convert it to polar. Convert it to polar. How do you know it's in rectangular? X's and Y's. How do you know that it's in polar? You got some thetas, you got some other things.
other things?
Oh, it's a lemniscate. A lemniscate. I thought it was called a lemisol. Cordioid. Oh, there it is. Lemisol. Lemniscate. Don't worry. It sounds like biscuit, doesn't it?
Let's say Triscuit.
All right. X squared. What's x in polar form?
Our cosine theta.
R cosine theta. So I'm going to substitute R cosine theta, and then I'm going to square. Polar form. What's y?
R sine theta.
R sine theta. Okay, keep going. Take care of the square. And do some multiplication. Square, multiply, etc.
Where did you get R?
4r squared cosine squared r sine theta. Okay, that looks super messy. That is gross.
R's make me puke.
All right, that's just icky. What do you got for me? What do you got? Multiply this out. What do you get?
4r cubed
4r cubed
cosine squared theta
cosine squared
sine theta.
sine theta. Continue. Stop.
Can you divide that?
That's not gonna help you much because I'll still have the cosine. Am I done?
Can you convert cosine squared theta to 1 minus sine squared theta?
Okay, so I did that when I was doing the problem. Cosine squared is 1 minus sine squared.
Go with y.
Well, I don't know. Let's see. I mean, like, does that help me any? I have one, what do you call it? I have one function, all sines, as opposed to a mixture of sines and cosines. So if you distribute the sine, you get 4r cubed sine theta minus sine cubed theta. I mean, from here, when you go from the cosine squared to sine, here to here, you're going from 2 trig functions to 1 trig function. Can you substitute for sine?
No.
No, but can you substitute for cosine squared?
Yes.
Yes. Am I done? Your book divides by 4 to get it 1/4. Like, are there any more substitutions that you can do? No. David?
So what's our goal?
That's a good question. I don't know. I sat down with the 2 other trig teachers. I sat down with Mr. McGurk. We're like, what's the goal? Learning how to convert from rectangular to polar.
No, I mean, what's the goal when we're solving these problems? Like, what are we trying to get to?
I don't know.
What do you mean? I'm confused.
Plugging in for sines and cosines, or well, in this case, plugging in for x's and y's. That's your answer.
So if you get a different answer.
You might stop here. You might stop here. My suggestion to you is anything that you can substitute for, like I can substitute for cosine squared, I would substitute. After that, I would, try and clean it up a little. I know that doesn't sound like much, but try and clean it up a little. Can you plug this into your calculator and graph it? So, I could make it a lot worse, if you'd like. Let's solve for R. Let's
That's what I
go.
thought we were doing.
Okay, great. Let's solve for R.
We're,
Let's solve for R. right? When you're trying to plug into your calculator, you want to isolate y. When you want to plug into your calculator, you need to isolate y. So if I'm going to plug this into my calculator, I need to isolate r. All right, let's try. I'm going to try and isolate r from here, since it's already all multiplied together. So if I want to isolate r, what should I do? From this step right here. Divide by 4. Keep going. Cosine squared sine. So we get r cubed equals 1 over. Sorry, that's really messy handwriting. I'll fix it. No, I want to solve for r. Cube root it. No, you don't have to rationalize because it's cubed. Well, actually, you do. You do have to rationalize. We are not going to. We are not going to rationalize. Cubed. No, yes. Should we rationalize? Yes. I'm not going to bother rationalizing that. You multiply by the square root of blah over blah. It just gets really messy. You want me to rationalize it, Sana? I mean, I will. Do you want me to?
Sure.
Okay. So we're going to rationalize this. I'm teaching this today in Algebra 2 Honors. So don't tell me you haven't seen it. So you're going to multiply by the square root of 4 cosine squared sine over the square root of 4 cosine squared sine. No. You're going to multiply. Hold on.
By 2 cubed.
Yes.
Yeah. But by 2 of them, right?
There's 3 what's?
Which is why I did square. So, okay, this is 1/3. So let's do the 2/3 power. That's nicer.
Yeah.
You can't. But yeah, that's 1/3 plus 1/2 is not 1.
No, but if you do, if this is to the 1/3 power.
No, I agree with that, but when you were just doing the square
Yeah, I
root-
know. That's why I erased it. I make mistakes, a lot of them. Cut me some slack. It's Monday. Look, you can blame someone off. He's the one that wanted to keep going. And how come no one's writing it down but me? Thank you. There are a few people writing it down, and I appreciate that. So you end up with, why would you want to rationalize this, especially when I tell you you don't have to?
Just thought I could go to 4.942.
I'm going to leave it to the 2/3 power. I'm going to leave it to the 2/3 power. And this is over 4 cosine squared sine. So that's what your r equals. I would have let you stop there. You want to stop here. Let me ask you a question. Which one do you want to plug into your calculator?
Top one.
Yeah, don't you want to plug this into your calculator versus this? Okay, well, fine. There you go. Let's graph some fun things. We're not going to have time to graph a lot of fun things, but let's graph some fun things.
That's all that's in 9.5.
That's all 9 point, what do you call it? That's all 9-1.
No, just graph.
So we're not going to get to a lot of it. Put the calculator away. You can play with your calculator later. How many of you know how to graph and polar on your calculator? Okay, so we're going to do 1, and then I'll show you how to do it on your calculator. We're going to be racing for time.
Looks like
It's
going on.
crucial against time.
All right, let's do r equals 1 plus sine theta. This is 9-2. you very first learn how to graph anything, what do? For the most part, without your calculator.
Draw. Line.
Draw a what? When you very first learned how to graph a line, how did you learn how to do it?
Plug in.
Yeah, you plugged in points.
Oh, that's what she meant.
Oh, look, here's the point. Oh, that's it.
Let's start with some things we know. So if theta is 0, what's the sign of 0?
Zero.
0 plus 1 is 1. Let's plug in values that we know that are pretty easy to find. If theta is pi over 2, what's the sign of pi over 2? 1 plus 1 is? Great, let's plug in pi. 3 pi over 2? Yeah? Okay, so we have, this is a clue to you about what the shape looks like. You have repeated values of r. That's going to help us figure out what the shape looks like. Okay, we don't have time to do it right now. I want to show you how to do it on the calculator, and I want you to practice doing the calculator with plugging in points. So I don't have much time. We need to like coast through this, and you're going to want to know how to use the calculator. Okay, so go to your mode. Go to your mode. Okay, so radians, and then below radians it says function, parametric, polar, and then SEQ, which stands for sequence. So arrow to polar, to polar, push enter. And when you go to your y equals, see now how it says r instead of saying y. And when you, to the right of alpha, the x key, when you push the x key theta n, theta will show up because you are now in polar. Okay, so let's graph 1 plus sine theta. So 1 plus sine, oh, what happened here? What's going on?
Yeah.
Why is it like?
It's like a circle.
It's not a circle.
What's happening?
The oval.
Then do a zoom 6 to kind of see it.
I know.
And it looks like a messed up, like, it looks like a jelly bean sort of.
Yeah.
But it's hard to tell that it's a jelly bean. Hold on. It's hard to tell that it's a jelly bean because you were so like zoomed in. So zoom out a little bit. So instead of going from whatever it is, like I'm going to change my x from -2 to 2. Okay. Will you play with it? Oh, I just tapped my. It should look like it's a flattened jelly bean. Why is your? That's because you have other things plugged in besides 1 plus.
Why does it look
Yeah, why does it look like a
What kind of jelly do you have?
We'll talk about why it looks like a jelly bean. Why does yours look like that?
Yeah, I'm in radian.
You're pulling for sure. That is weird. 1 plus sine of theta.
What do we know that one?
Graph it by. No, hold on to it. Graph it to check. Play around with plugging in points. We're going to do more polar graphing tomorrow. What's going on with this? Yours is messed up.
Is the homework that homework?
The homework is that homework.
Okay.
Wait, what about the one who did their homework?
I will do it all tomorrow, so turn in nothing to me right now. I don't know what's going on. That's really messed up, Chris.
Time to hit the reset button.
Fraction type, math credits.
You feel like
I don't know, Chris.
I'll just look at the manual. Yeah, but I get like Thursday.
Because this is showing up in degrees, not radians, on your screen. You're
Thank you, Miss Abby.
yeah, I'll see you guys tomorrow.
That's fine.
This is really strange.
I only
No, Zoom 6. I did a Zoom 6, it's fine. I don't think I collected anything on right next Friday.
Thursday. Or Wednesday, sorry.
Okay.
Jessica.